So in this problem, we need to check whether if 3 points with the following position vectors are collinear or not. Let us begin. So first, what we'll do, we're going to consider 3 points. Let's say we have the point P, point Q, and point R. We're also going to consider another point O, which is going to be the origin of some coordinate system. Now, we can define the position vector of point P with respect to the origin. All we have to do is join point O and point B with the help of a directed line segment. Similarly, we can define the position vector of point Q and point R. So here, let us assume that position vector of point P, let the position vector of point P be defined by the vector OP. The OP vector such that OP vector equals to, here we will consider A vector minus 2B vector plus 3C vector. Similarly, we can define the position vector of point Q such that we get OQ vector equals to, we'll take negative 2A vector plus 3B vector minus C vector as the position vector of point Q. And then we will consider the position vector of point R to be OR vector defined by 4A vector minus 7B vector plus 7C vector. Fine. Now what we'll do, we'll join point P and point Q with the help of a directed line segment going from P to Q, and we are going to now find out the value of the vector PQ. So PQ can be defined in terms of the position vector as OQ vector, the final point, position vector of the final point minus the position vector of the initial point, which is OP vector. So let's substitute these values here. OQ vector, so that's negative 2A vector plus 3B vector minus, this is 3, minus C vector. And from here, we're going to subtract OP vector. So that's A vector minus 2P vector plus 3C vector. This is going to give us negative 2A vector plus 3B vector minus C vector. Then we have negative A vector plus 2B vector minus 3C vector. That's going to give us negative 3A vector. So 3B plus 2B will be 5B vector, and negative C vector minus 3C vector will be negative 4C vector. So this is the vector PQ. We're going to label this as number 1. Next, what we'll do, we'll join point Q and point R with the help of another directed line segment going from Q to R. So now, again, we are going to define the vector QR. So QR will be simply, in terms of the position vector, OR minus OQ. So what is OR vector? So we have 4 times A vector minus 7 times B vector plus 7 times C vector. And from here, we're going to subtract OQ vector. So that's negative 2 times A vector plus 3 times B vector minus C vector, which is going to give us, so we have 4A vector minus 7B vector plus 7C vector. So negative times negative 2A will be positive 2A vector. Negative times positive 3B will be negative 3B vector. And then when negative times negative C, that will be positive C vector. Now 4A plus 2A, that gives us 6A vector. Negative 7B added to negative 3B will be negative 10B vector. Then we have 7C vector plus C vector, so that's going to be positive 8C vector. So this is the vector QR. So QR vector is 6A vector minus 10B vector plus 8C vector. Let's label this as number 2. Now what we'll do, here we see we have QR vector. So let's start with the vector QR. Now in this vector QR, let's do one thing. Let's take negative 2 as the common vector, which means that we have negative 3A vector plus 5B vector minus 4C vector. Right? Now what is negative 3A vector plus 5B vector minus 4C vector? So that we have already defined in one as the vector PQ. So QR equals negative 2 times the vector PQ. Now we have a condition here. So we have a vector QR, and this is equals to some scalar value lambda times PQ vector, where we have considered lambda to be equals to negative 2. Now this particular relation tells us that the point P, Q and R must be collinear. So we have successfully verified that these 3 points P, Q, and R, which are defined by the position vector, a vector minus 2b vector plus 3c vector, and the remaining are indeed collinear.